Okay, let's talk about the 670 version 3 power supply. This is the second iteration of it. It's a bit smaller. It's more uniform. Everything is sectional and defined a bit much more clear. The silkscreen is 100% correct on this, so there is no alterations to the polarity of the bias diodes on the last one. One of the notable things is that I removed the primary distribution from the AC mains into the transformers. That was a more safe approach to this, simply that if there was a catastrophic failure, that the board could be destroyed by the AC mains, and I think it would just be more secure and professional to actually keep this on terminal blocks and secure those. We'll start off with the high voltage section. You should treat this area with respect. It will rip your face off. It's 200 milliamps, about 750 VAC, 400 volts DC. The component complement is actually really small. It's 4 tubes and a handful of resistors and then electrolytic capacitors. I've adjusted the spacing on the secondary hookup to use PCB mount terminal strips that have screws on them, so you can use fork connectors or tongue rings to secure these wires to each of these positions, which is this approach is much more safe than soldering to the PCB using small Phoenix connector type terminal blocks. Here you will need one ground to the chassis, and that's important. The whole ground is connected, so you don't have to ground multiple grounds that make this more confusing. High voltage center tap is HVCT. That actually leads to the 5651. So when the 5651 is not installed, the center tap of the high voltage is not connected, disabling the high voltage. So it's sort of a safety precaution that was designed into the original schematic. This is the original high voltage regulator using the 5AR4 tube, the 5651, the EL34, and the 6084. Here you can install the oil-filled AC, the motor run capacitor here by connecting wires into these spots. Capacitor technology has advanced so much that the high pulse WIMAs work great here, rated for 600 volts DC, and there are some specifically designed for AC that fit a 27.5 millimeter footprint. So besides the resistors, keep everything 2 watts. You can reference the actual schematic and see what needs to be 2 watts, or it can be half watt. It's your power supply. You want it to last forever. Make it 2 watts. I mean, these are very common resistors: 100K, 470K, 270K. Jump everything that says jump on it, or JMP, and use insulated wire or insulated jumpers. Exposed wire is not really acceptable because the entire top plane is a sheet of copper. If the solder mask was to wear off, you have a major short. The voltage adjust, it requires shielded wire. If you do run it to the front panel, you will need 3 conductors plus a ground wire, which is usually called 3 conductor plus drain or 3 conductor plus shield. There are for a normal potentiometer, so it's pin 1, pin 2, pin 3, and ground is the shield. I added a larger hole here that you can mount a locking potentiometer if you do not want this voltage adjust, which is a good idea since it's over $1,000 in tubes. So you can mount that here, and then you don't need shielded wire. You just wire to the potentiometer, skip the ground. You have 2 test points. I would add professional test points. They're available at DigiKey. You can stick them there. That way you can attach your multimeter. Optional, just loop a piece of 18 gauge wire so you can clamp on your multimeter. Tube sockets should be gold plated, except the 7-pin one for the 5651. You can find those on eBay, but they're not. You're not going to get them on a Tube Depot or Antique Electronic Supply. The octal sockets, pay attention. If you mess up the alignment of the octal socket, the keyway should match this line. On octal sockets, there's a keyway where the tube can only fit in one way. Align that dimple to this line. If you don't, you risk frying the board or frying the components, or it just won't work. So pay the hell attention in this area. Pay attention to the electrolytic capacitors. These top two are for the regulated 240 volts, and these four are for the high voltage 440 volt line. If you mess the polarity up on these, they will pop. So, and they could damage other components. So take note on that, because cleaning up the electrolytic off all of your shit sucks. So note that. All of this this area, use a lot of caution. I mean, the choke will be carrying 460, 470 volts. So just make sure your wiring is not flimsy. Make sure that you use heat shrink on the connections on the tongue rings or the forks, that they can't edge to the side and short each other out. So use a hell of a lot of caution. Make sure your solder joints are on the top and the bottom. Just kind of go over it, make sure this is working, because this is the life and blood of the unit. This regulator and rectifier control the voltage to the $1,000 set of 6386 tubes. So you want to pay attention when you do this. Okay, next over is the power supply for the heaters of the high voltage section. These are all the same. I made them uniform and identical so there was no confusion. Each one will use a 953 resistor, a 470K, a 0.1, a 240, and an LED drop. The LED lights will tell you when this section is active. So if you have a miswire in one of these, you don't have a light, so it'll kind of direct you towards what you should be looking at. And it's also a good way to not kill yourself by knowing the unit's on. The electrolytics, I like to keep them 10,000. These two are on the output of the voltage regulator. These two are on the input. They do make 16 millimeter, which is the size of these, 15,000 UF. That's just pimping this out, so you can also use those. 10 volts is perfect for this because it's such a low drop that there's not enough voltage to go over that, so that will suffice. You have one trimmer on each of these sections. For the 6.3 sections, it's going to be 50R. That allows for precise adjustment, get it to exactly 6.3 DC. Tubes don't really freak out if it's 6.5, 6.2. It's quite fine. The reason I added and switched to DC regulated power supplies for this is because the tubes are about $1,200 and the transformers are about $1,500 to $1,500. So right there, one of these, if there was a power surge in the heaters alone, you would lose quite a bit of money. So this was the most logical approach due to the high price of those components. The diodes are all the same except for the bias. So these are all STP S5L40s. The silk screen is correct on the entire board. This section is for the secondary of the transformer. You will use a terminal block with screws or spade connectors, and you do not need to ground each of these. That was just gratuitous. So you'll have one ground coming out of the board. You only need two connections for this. The secondary, the transformer, you cannot ground the center tap of any of these. If you do, all the the diodes that you did die. You would normally use the terminal blocks that you mount the primaries to. You would secure the center tap. There is a footprint for the small fans that I normally have. You would connect the fans power here and add a 50 ohm trimmer. This can be awkward as hell once it's installed with all of these little fans, each individually controlled. It's a cool option, but it's fine if you if you want to do that. Otherwise, the better solution would be to wire all the fans together, ground the black lead, and connect the red lead to a 100 ohm potentiometer and mount that to the back of the case. And that way you can control the fan noise externally and not have to be sticking your hands into a mess of high voltage or over the tubes, because it will get cramped depending on the size of case you use. So that's an option. I'll break that down how to do this. I did adjust the size of the heat sinks to a smaller footprint. So what this allows for was more uniformity in the design. And also, since I was using LDO heaters, LDO voltage regulators, that there wasn't so much excessive heat. However, you do need cooling across this. In the bias supply, if you do use the LM337 to control the 6.2 bias, you might consider mounting that off to the case, because this one actually gets really hot, or have an external fan blowing this towards this way. Otherwise, you can use the traditional choke, and you don't need to add any of this shit up here. But I'll have both ways, where you have it regulated, or you have it the natural original schematic design, which on this, only the minus 6.2 bias going to the 6386 tubes is regulated. The bias going to the control amplifier is not. It's done traditionally. Once again, I chose to regulate it because it is $1,200 in tubes, and that's pretty much, back then there were a dime a dozen. So you have the choice here on what you feel is right. Some people do use new old stock tubes in this design, and they do spend up to $2,500 just for those tubes. So the bias diodes are 60 volt, as where everything else is 40 volts. So keep those at 60, and that way you have plenty of room. You don't have to use anything more than 0.5 watts or half a watt. If you can, do use 1 or 2 watts. It just what it means is it lasts forever. The 240 and the 953 R's the voltage setting of the regulator use 1%, so you might just use half watts there. I've added additional holes for external voltmeters that you can get on eBay or DigiKey, and those are actually really cool. They're not the most accurate things on the planet, but you can adjust them with a screwdriver to make them damn near close to the actual voltage. So what those will do is they'll give you an idea when you turn it on that everything's operational. Everything's kind of within tolerance. That saves a lot, rather than using a $50 Murata meter, which that's just $200 a meter, so fuck that. So, and you would power the meters from the from these taps here. I've added that, and the footprint does fit those Amazon DigiKey voltmeters, and I do like them. The 12 volt section, you don't have to go anything special here. It's just for the relays and the lighting. So these optional caps, you can skip them if you want. You don't have to use fancy things here. I still do use an LDO voltage regulator here, but that's just simply to keep the design uniform and save me that extra space for the magic that can happen over here in the future. All of the power supplies have adjustment trimmers. You can adjust these. They're pretty spot on, so these trimmers will only adjust several volts. So even when you turn it on, it's going to be in the relative ballpark of where they're supposed to be. The bias is the same. There's a couple protection diodes for the voltage regulator. Keep most of the capacitor 63 volts. That just makes it so it's secure and lasts forever. I would use high quality components for the high voltage heater and the two left and right channel heaters. Use good components as best you can afford for these sections. I mean, you want the tube heaters to be happy. So these are some great designs for the heater circuit. So these will really keep the noise floor down for your audio path, especially in the power, in the voltage regulator section. Up here is the power distribution. Once again, I've made it so it's spaced for terminal barrier strips that you will use fork connectors or tongue rings, and these two left and right use 18 gauge. It just keeps, there's a lot of amps going through the heaters, so keep it that way. And the high voltage, they should be durable. You'll have 240 and 440 unregulated, and then 6.3 minus is ground. I put minus in case you were floating any of these and it was elevated, then you would have to use the negative multimeter terminal on 6.3 minus. But the 6.3 minus, just consider that as ground. It's not 6.3 bipolar, so just don't get that confused. The bias only needs to be 22 gauge. You can use shielded. It doesn't really matter. Just keep these bundle wired same color code left to right for each section. Use 4 colors of wire, and then do them one at a time, and then label them when you're done with the run. It only has to go down to about right here, and then it connects to the board. So you'll do those connections. Make sure those wires are not getting scratched or anything like that, because they, like I say, they do carry the lifeblood of the 670. That pretty much concludes it on this video, but I do want to just point out that this area really requires a lot of attention. If you don't understand what you're doing, ask. If you're not sure which component goes where, ask. Just don't guess at any of this. If you don't understand it, it needs to be thoroughly explained to you, and some of these videos will actually do that for you. So keep it up. Later.